in the previous session, we were looking at the multi-class classification, and we understood that in case of a multi-class classification, we are going to have the number of classes greater than or equal to 3. So under such condition, we have to make slight modifications, right, in terms of the neural network architecture. So this is the first point we observed, and we first took an example of say 3 classes, right? We decided the number of input layers required and number of output layers, and the data points every data point have 2 coordinates in this example, and we took 3 output nodes because there were 3 classes. All right, so because of this we didn't consider any of the hidden layers as such. Then the next important concept was we had various classes present, and the classes were identified by different shapes in the example. So as a result, right, we have to add the class name to the training data like this, but the names as such, class 1, class 2, class 3, etc., is difficult to handle when it comes to the MATLAB or any programming environment. So what we require is we need to replace these values of the outputs by a vector such as 1 0 0 0 1 0 0 0 1, etc. So after updating, you know that the training data looks like this. Okay, so then we have to look at what activation function should I use, right? If I use the same activation function like previous cases, right, we have the problem of multiple neurons firing at the same time. So now we just want to eliminate that, right, completely from our design, and our idea is that we want only one neuron firing at a time. Only one neuron's output should be high. So in case of the sigmoid function, which was the activation function which used in case of the error back propagation or any other sort of this thing, the basic idea is that we have to the activation function did not consider the outputs of other neurons. Whenever you calculate the output of a neuron, right, it never took care of the other outputs. So that's a basic problem, right, because of which the neurons output is independent of other values. So in order to overcome that, we define what is called as a SOFTMAX activation function, and this is only applicable for the output layer because, right, only output is expected as if I have 3 neurons in my output layer, I just want one of them to fire, right? So that's my idea. So because of that reason, I just apply this SOFTMAX activation function to the output layer, okay, only to the final. Okay, so that's the first thing. Then let's see the idea here is that we assume an output v is equal to 2 0 2 1 and 0.1, and if we apply the softmax, right, 2 of them will fire. So what we do, we try to modify that by making an idea that whenever you want to say design the output or obtain output of a neuron, you should consider the outputs of other neurons in the same layer as well. So for example, you see the 2 1 and 0.1 were the values. We took e to the power 2 in the numerator for the first neuron, e to the 1 in the second neuron, e to the 0.1 in the third neuron, but denominators are same. You see all the other neurons outputs are considered, right, because of which now you see that only the highest one, whichever has the highest value in the v, right, vector, is going to get a highest value. Anyway, we can tune this further when the machine learns. It can be, right, brought close to 1, right? So the idea is pretty much clear over here. Because of this, now we define the the activation function of the output layer, we update that, we remove the softmax, and we remove the sigmoid, sorry, and we bring in what is called as the softmax. So this is the idea, right? So then we actually consider the step-by-step procedure, how to, right, solve any problem related to this. And then we consider an example of binary image classification. So we considered 5 into 5, right, binary images, 5 classes, 1 2 3 4 5, right? So we then design the ANN, right? Input layer should be 25 nodes, output layer is 5 nodes because 5 classes, and softmax activation function needs to be used. And the hidden layer size, we try to make it 10 times the number of classes, right? That is just rough rule. You can even vary that and it will work. Okay, so 50 nodes we defined, and the sigmoid function was used for as an activation function for the hidden layers. Okay, so this was the theory part behind the requirement, and then we moved on to the MATLAB window, and there we first wrote what is called as the program, right? In which first objective was to write a function which is used for a multi-class training, right? So you can see that we define the number of classes, right? We provided the input. So for a training, we need x and d as the training vector and the desired vector respectively. So v1, y1, v and y are the outputs of hidden and the output layers respectively. Then calculate the error, right? And update the weight dw1 to get a w1 updated. Similarly, dw2 to get the w2 updated. So this is how the training takes place. So once the training is over, we went for the testing part. So right, so define all the 5 classes and pass it, right? Before passing, you define the weights at random. uh, do the training with the so many number of epochs. In this case, we took the epochs size as 10,000, right? 10,000. Then n is equal to 5, so we can see that for j is equal to 1 to n, right? All the 5 numbers are passed on to this, and later on we check this. Let's quickly run this and see what was the result, right? We can see that they are perfectly classified, right? First data, it belongs to the first class, second one to second, third to third, fourth to fourth, and fifth one to five. So only one neuron fires at a given point of time. That's very clear. This is what our intention was in case of a multi-class classification by using a artificial neural network. All right, now see, in this case you can see, okay, in terms of the testing data, one thing is very clear over here. That is, we try to give the exact image, in the sense whatever was the training data, that itself was given as a testing data. That it should be very clear now, right? You can see that the testing data which you can see here, right, is actually coming from where? Is coming from the same x itself, right? So you see the x of whatever we are writing here, right? So it is nothing but it is the same training data, right? So training data itself is given as a testing data, means you can expect 100% accuracy most of the time, right? So this is something like, I exactly teach you what's going to come in the exam, and you study and you will definitely write completely, right, if I ask the same question, right? So that's the very fundamental idea behind this kind of training, where the testing data is same as the training data. Right, now we'll go make it more practical now. So this should look like a mini project for you, right? So let us try to do one thing. What I meant when I said the input data and the training data are same, right? So I mean this, right? I'll just copy one diagram and I'll just paste you. Okay, so whatever I trained, I'm trying to give that itself as my testing data. So in this case, so let me just write what we did so far. So this is case one, right? The testing data is same as the training data. So what happens now? Machine will definitely classify. We already have seen that. So something like this, the one which was represented in this fashion, I try to give the same as input, right? So one means it is exactly same. So same thing which I used for training, right? You can check that even in case of our, I'll go back to MATLAB to show you that. So just check what was a one, right? So the one is actually, let's go to x of one. You can see that this is, right? This is what is one. I can see the one over there, like wherever I have the bits defined as one over there, it corresponds to the where the dark color exists when I write a one, right? So I can actually do the same thing and compare now with this. You see, it's the same one. So my testing data and the training data are going to be same. So because of which the machine recognized everything perfectly. So it's like you see the values are coming as exactly 1000 or 0100, etc. Right? So classification is perfect over here. This was a case one, right? Like all the other cases which we had done so far, we did the same thing now. But now I don't want to go with that. I want to make a practical scenario, right, in which, right, I don't want to give the same the training data as a testing data. I just want to change it, right? So this is, say, the case number 2, in which you see what I'm trying to do here is that the testing data is not equal to training data. So this is a scenario where you are actually trying to check how much there is learning, how much the machine has learned, right, related to the problem, right? So if at all you say that machine has learned properly, even when you give some unknown data as a training data to the machine should be able to classify, right? May not be with 100% confidence. Now you see the results came as 1, right, 0000. Where is a 100% confidence? Machine says that okay, this data belongs to class 1 with 100% confidence. It may not be that much confident when you give a new data like unknown data, but you still expect highest value for that class to which it belongs to. Like if at all it belongs to a second, the digit you have given is 2, the second neuron should have more confidence compared to the other neurons. This is what we are expecting. Let's try that. Okay, so that's what's going to come in today's session, right? Okay, so let's try with that. So my idea is that, see, I will not give a perfect data, right? I'll slightly modify and let us compare, right? So let me try to give the testing data that I'm going to give now should be something like this. Let me see. Okay, so this is what is my testing data now. Training data will not be changed. Training data is still same, but the testing data, right, for testing purpose, I'm going to give this data. Okay, so let me just paste this. So you can see that this is actually, there is slight difference, right, among the training data and testing data. I can show you the training data which we have already pasted over there. So this was the perfect data, right? For 1 2 3 4 5 I had given like this. So now you see that this is the what I have pasted now is the testing data which I'm going to give, which is completely different than this. Okay, so you can see that they are different. Okay, so because of this, now I'm very curious to know that what machine will do, right? So there are two different ways in which I have written 5, and these 5s are completely different than the 1 5 which I am training, correct? So will it be classified exactly close to that, or is there any difference? This is what I want to test. and I can see that, right? You can see, right, the 2 is actually slightly modified by adding one, right, bit over here, and the 3 is also modified by making some changes and so on, right? So instead of 1, this looks like a something else. It's close to 1 as well as 4, the first number, right? I don't know how it's going to classify. Let's see. So our intention now is that we'll write another code and we'll give this data as a testing data. Okay, yeah, so now we'll move back to the MATLAB window and let's see what happens and how the machine is going to classify. Okay, so let me go to a new window. I'll call it as maybe real. I'll call it by the name real multiclass. Okay, now, so according to the data which I mentioned earlier, I'll try to write the data set now. Okay, so now clear, close all, CLC, right? So everything will be clear. Now you see, actually the training is going to take place according to my previous program. Previous program, I already have written that how the training takes place, isn't it? So I can actually perform the training directly from there. I don't have to write what is called as the testing part. I don't have to do the training once again, right? What you can do is simply call that name of that function. Sorry, not function, name of that particular code. You see, this is the code where the complete training happens, right? So I just don't want to look at the output, so I suppress my output by making it as a comment. Okay, so last one, this line I comment, so that in my previous program the output will not be displayed if you run. Okay, so I just run that. You can see that output is not coming, right? So I suppress the output. So this is the name which I need to type here. So I just run that program before this, so that there is a training happening automatically inside, right? So I'll just write test multi class, right? So it means you are calling that whole program to run, right? Just before you run this particular code, which is real multi-class. So what happens over there? Everything will be done, and there is a training. Training happens, and your updated weights will come in the W1 and W2. This is one option. Otherwise, I'll tell you the second option. If you don't want to do that, simply copy this, right? Till here. This is also the other option. Let's do that, right? You simply copy it and you can paste it. Either you do like test this, or I suppress that and I'll write what we are going to do now. So simply paste it, right? So at the end of this, right, you see you define the actual data for classes 1, 2, 3, 4, and 5, right? Then you told what is the desired this one values. You defined your initialize the weights as random, then perform 10,000 iterations and you did this. Okay, so this is going to happen, right, whenever you run this, right, for the first time. So then now what you want, I want to change my testing data. So testing data is completely different, right? So you know that now my intention is not to give the same testing data like a training data, and I just want to give the first row of this diagram what you are seeing now, right? So there is one, right, there is difference. It's not same as the one which we gave for testing training, my mistake, right? So anyway, since we know that, I can remove the second row itself now itself, so that it becomes very clear what I'm going to give as a testing data. Okay, right. Now, so in MATLAB now, my intention is to define a new vector, right? So I'll start defining that by from here. what I do, I'll write, say, a new vector I'll create. Okay, so this is my testing vector. So y is equal to, right, I define zeros. I assign zeros initially of how many rows? 5 rows, 5 columns, and 5 pages. It will be created like earlier. And then let's define each and every values of this y. Okay, so this is y of all the rows, all the columns, but the first case. This is my first test data. Okay, equals to define. So this should be 0, 0. I'll make it as say 1, 1, 0. Then same thing, I'll repeat 0, 0, 1, 1, 0, 0, 1, 0, 1, 0. All right, so this is my first data. Then I'll move on to the second data. So this is y of all the rows, all the columns, and the second page should be equal to, I'll give different data, and it's none of the training data. It's not present in any of the training data. Okay, so this is 1, 1, 1, 1, 0. Zero, triple one, 0, 1, triple 0, 1. Okay, so this is the second data. Then I'll write y of say all the rows, all the columns, and the third one should be equal to 1, 1, 1, 1, 0, 0, 0, 0, 0, 0, triple 1, 0, 1, triple 0. Then this is 1, 1, 1, 1, 0. This is y of all the rows, all the columns, and the fourth page. Okay, so this is equal to 0, triple 1, 0, 0, 0, triple 1. Okay, 0, 1, then I'll write triple 0. Okay, then 0, triple 1, 0. 0, 0, 0, 1, 0. This looks pretty good. And I want to modify. So let me write this as 0, 1, 1, 1. Okay, 0. Close to 3, but not exactly 3. All right, okay. That's the fourth one. I just want to give another testing data. Say y is equal, okay, y of all the rows, all the columns, and the fifth one. Okay, this is equal to, then, okay, so 0, 1, 1, 1, 1. Next slide, 0, 1, 1, 1, 0. 0, 0, 0, 1, 0. Zero. So these are the five data, five matrices which we have entered over here. Okay, just to represent this data, which is not as the same as the training data. This is a different data. So we call it as a Y in terms of the name of the matrix. Okay, so this name of the matrix, we change it now like this. All right, then. Okay, so what's the next objective? Next objective is to simply give the perform the testing. Training is already done, no need to do the training. Simply we'll start with the testing part. So in the testing part, so it's only the testing code, only give y as your input, that's all. Okay, instead of x, you give y. So just check the same code which we had written earlier. I'm trying to write the same thing, but with the modification that input is, the training data is different. Okay, so say for how many data I have for say I is equal to 1 to n. Okay, I don't need the bracket. For I is equal to 1 to n. First, what you do, get your x, right? So training data x is equal to, I can give the y itself. So small y is equal to capital Y. Okay, so since this is a bigger size, it's a three-dimensional matrix. I have to convert it into one dimension and single vector, right? Single, either a row vector or a column vector. So I should use a reshape, I guess, right? So just refer to the previously written code, right? So I'll perform a reshape. Reshape of which one? Of your y, right? What you want to do, right? Go to take all the rows, all the columns from ith page. Okay, so that's why colon comma I. Then what is the new shape you want? New shape is nothing but 25 rows, one column. So that's a y. That's my testing data, right? So if you have this testing data, directly give it to the first layer. How do you get the first layer's response? We call it as V1. So V1 is nothing but multiply by weight to this input. So weight is W1 already there. You can see that W1 comes from here. W1 and W2 are there with us. Okay, so the V is W1 into this Y, which is the input testing data. So rest remains same. Hidden layers activation function is called as a sigmoid function, right? So we get the output y1 equals to, this is my sigmoid of v1. Get you an output. V is equal to, apply the second weight. All right, second set of weight is the output value, multiply that with the y1. All right, then what you do now, you got a V, that is your output. Calculate the final output Y, right? Oh, there will be a, I'll just make this as different Y. Okay, so I don't want to call this Y because it's my output, so I'll call this as X itself, right? So this is the small x, right? So this actually takes the value to x. X will be calculated to v1. V1 is used to calculate y1. Or I can make one more thing. Let me keep the name y itself, because y is already used as the different one. I'll call it as a y2. That's all. Okay, so I'll call this as y2. So y2 is equal to, we know that the output layer of a multi-class neural network has to be, the activation function has to be the softmax. Okay, so of this v, okay, now, all right, let me end. Let me check what is going to happen. Okay, let's try to run this first and see. Okay, my softmax is defined this way. Now let's run this. Okay, we are getting some outputs, but it's not very confident. What we do, will like the previous code, at the end we'll write what is called as the class and y we try to concatenate. So just before this, I'll make the class equal to, then we got this, and class is equal to, perform a concatenation, class space y. Once everything is trained, now I'll ask the machine to show me the classes. Okay, let's see. Okay, it's not y, my mistake. This should be y2, right? Sorry. Because of that, it's creating a very big matrix. See. Yeah. Okay. Now you see that. Let's go back to the testing data. Okay, I'll just show you the testing data for the time being. So you can see that the first data is neither 4 nor 1, right? This data. Look at the first data. So this data is neither 4 nor 1, but it is very close to 1, right? It's not 4, but definitely it is close to 1. Now let us see, right, what the machine has classified that as. Just check the class of the first column. You can see that the first column is for the first testing data, and 5 neurons values are shown over there. First neuron fires with a confidence of 70%, 0.7. Others, you compare to this value, others are, right, different. You can see there is this very less similarity with 4. It also identifies that, okay, there is a component of 4 in it. It is 28%, right, 0.28. right? So it is confident that, okay, the given number is 70%, and there is a confusion of 20% that, okay, this 28% that this may be 4. Same thing what I told, right? You can see that, right? Let's go further. Let's move to the second data over here. So look at the second data. Second data is exactly same as 2, except only 1 point, that is at the end, right? Only one pixel value is actually extra over here. So this should be coming closer to class 2. So just check this. So in your output, look at the second one, right? The machine is 100% confident that it is not 1. So there is no value coming at 1 at all. 1 is completely 0. So second one is 9984, 99.8%. It is very sure that yes, this number is 2. right? Then you see there is a very little bit confusion about, right? Very less confidence of other values, 0.0015, 0001, etc., right? For the other classes, right? Moving on to the third data. Again, this is exactly 3 except one point. At a particular point, I have added a new, what you call, point, right? So I'm expecting this to be classified exactly as 3, very close to 3. So you can see that it's not 1, it 4% that it may be 2, 95% it says that it is 3, and 0%, 0.002002 for other classes. Okay, so let's move on to the next one. You can see this is right, it is the next data is 5. We can read that it has 5, but compared to the training and the testing data, right, we have never trained 5 like this at all. Okay, so you see there is a confusion, right? So this is, there is a lot of confusion with respect to this number, the fourth class. You can see there 30% that says it is 1, right? 9% for 2, 41% for 3, and 17% for, so it's not clear because you never trained 5 like that in the whole case, right? So that's why it is, there is a lot of confusion. Let's go back to the last one. So this is also 5, but this is more clear, right, compared to this, right? So you can see that machine is able to classify with 87% confidence that this is right. This is what, this is the last class, that is 5. Okay, so this is one thing. Now let's try to do one more thing here. Let's try to increase the training, and let's just try to see what happens. Will there be any improvement? So I just increased the training samples, the epochs we increased, right? Is there any difference? No, right? Now if I increase further, still no improvement. It's very, second one is classified, third is classified, fourth one still there is confusion, fifth one you see there it's not classified, fifth one is not classified now. Even the first one, I think there is some confusion. So the first data, right, is being classified as 4 now. You see it is not 1, correct? So which was, I thought it is 1, but now you see there is 97% confidence that it is 4 now, correct? Right, let's do one more thing. Let's increase this once again and let's just check what's going to happen. Okay, it's still running. I can see here it says that if whenever I will see this kind, right, so it says that it is actually running. Also I don't see the arrow marks here in the command window, so it's running. Let's wait for another 2 minutes and see. Okay, it's taking too much of time, right? Okay, let's do one thing. I'll just pause it. Let's see. Quit. Okay, let's do the analysis of what exactly has happened over here. Okay.